So last topic in the first module is quadratic form. So quadratic equation is usually ax square plus by square plus cz square plus 2fhx 2fyz 2zxy plus 2hxy, which is a quadratic form. So write down here. See, I will explain later. I will come back. So ax square plus by square plus cz square plus 2zxy plus 2fyz plus 2h xyz xz or zx. This one. This is written in the matrix form. I will explain one by one. Here first row x corresponding, y corresponding z, x, y, z. You keep in your mind. X into x, x square. That means x square coefficient. Easy. X into y, xy. Xy coefficient is 2z. But here also y into x, we get xy. Y, x, nothing but x. So 2z is there. You divide into two equal parts. Here g, here g. Total is 2z. X into z, xz coefficient is 2h because zx here and here diagonal entries. That means symmetric matrix. First row is same as first column. Here we have h. Diagonal entry is y into y square. Y square coefficient is b. Here we have c. Y into z means yz. Yz coefficient is f. Keep f. This is the matrix. Usually this is nothing but take x, y, z into or column matrix x, y, z, x transpose. Usually this is nothing but x transpose ax. A is 3 by 3. For example, this is 3 by 1. Transpose of 3 by 1 is 1 by 3. Finally, we get 1 by 1 matrix. Usually x means column matrix is row wise. If you take row wise, it is a transpose of x. X transpose ax equal to this one. X transpose is xyz. A is agh gbf hfc into xyz. After multiplying these three matrices, we get this above form. This is called quadratic form because second order degree equation. So quadratic form of the matrix A is this one. This matrix form or this form. You can represent. Here always A matrix should be symmetric. That means after interchanging rows into columns, columns into rows, we get the same value. This is called quadratic form. Normal vector. Normal vector means vector multiplied with unit vector. For example, take 1, 2, 3. This is vector x value, y value, z value, either column wise or row wise. So take its modulus value. Usually modulus of the vector is square root of 1 square plus 2 square plus 3 square. We get how much? So 1 plus 4 plus 9, 14. So this is vector v. Normal vector means unit normal vector. Unit, this one usually. This is modulus. V by mod v. That means 1 by root 14, 2 by root 14, 3 by root 14. This gives the normal, unit normal vector. So this is the definition for normal vector. Already I mentioned. You can take either row wise or column wise. Vector means usually it is a single row or single column. In matrix theory, vector means single row matrix or column matrix. Here I am taking column wise because in the textbook they follow the vector means column vector. X bar means x by square root of x square plus y square plus z square. Likewise, this is called a normalized vector of x. Proceed to reduction of quadratic form to canonical form. Canonical form means remove these terms. Only we have ax square plus by square plus cz square. This form is called canonical form. So first step in reduction of quadratic form into canonical form, first step is find the eigenvalues and its corresponding eigenvector. Normalize each eigenvector. Normalize each eigenvector of the row. Then consider the matrix P, whose columns are above normalized vector. We get P inverse AP equal to D, where D is a diagonal, whose diagonal entries are corresponding column eigenvalues. The reduced canonical form of the matrix A is X transpose dx. Okay, we are going to see one problem. It is useful to you. Later I will discuss other concepts. Here we have a problems, even though I am taking my favorite previous example one more time. One more time I am picking last example, because already we have ready-madely we have eigenvalues and eigenvectors. So that's why, for time saving purpose, I am picking same problem over here also. Up to eigenvalues and eigenvectors, I am taking common. Yes. Coffee. And paste in our document. Where is our document? Our document is 20th. Okay. In 20th document, I am going to paste here. Now question is slightly changed. Now our question is not find eigenvalues, eigenvectors. Canonical form. Reduce canonical form of a matrix A. But here also it is not useful. Not useful to us, because canonical form always symmetric matrix. Anyhow, we will try canonical form, because symmetric matrix means diagonal matrix is always symmetric matrix. Okay, find. Our question is procedure. What is the procedure? Procedure to reduce the quadratic form to canonical form. Quadratic form to canonical form. Reduce the matrix matrix of quadratic form to canonical form. So whenever you see the quadratic form to canonical form, first step is first find eigenvalues, just like diagonalization form. Then eigenvectors up to this common. In place of P, we take normalized vectors. Here, therefore, up to this, okay. Therefore, matrix P, normalized vector, not P. P is a vectors, eigenvectors. It is better to indicate with P star. P star is this one. Eigenvectors corresponding to eigenvalue lambda equal to 1 means 1, minus 1. Already we saw. Here, 4, 1. Now find actually better to find normalized vectors. Later you take P. Better. Normalized vector. X1, let x1 equal to 1 minus 1, because the first eigenvalue. X2 equal to second eigenvector. Eigenvector corresponding to 4, 1 eigenvalue. We have two eigenvectors. Now normalize this. X1 cap. X1 by mod x1. That means 1 by square root of 1 plus minus 1 whole square minus 1 by square root of 1 plus minus 1 whole square. That means 1 square. Don't think badly, because square root of a square plus b square plus c square form. So it is equal to 1 by root 2 minus 1 by root 2. This is normalized form of the first vector. Similarly, normalized vector of the second vector equal to x2 by mod x2. 4 by square root of 4 square plus 1. 1 by square root of 4 square plus 1, which is equal to 4 by root 17, 1 by root 17. So x1, x2 over. Therefore, normalized vector P equal to x1 cap, x2 cap. In case of diagonalization, no need to caps, only x1, x2. Now here you take x1 cap, x2 cap. 1 by root 2 minus 1 by root 2, 4 by root 17, 1 by root 17. Therefore, find P inverse. P inverse AD minus BC 1 by root 2 into 17 AD minus det of the matrix. Four by root 2 into root 17. That means root 2 into 17. Totally 5 by 34. This is det. Therefore, P inverse equal to 1 by det P into, interchange the values, 1 by diagonal values, root 17, 1 by root 2, and change the sign of the off diagonal elements. This one. Det P is 5 by. If you have a confusion, you write down root 2 into root 17, not 7. 1 by root 17, 4 by root 17, 1 by root 2, 1 by root 2. Now multiply the matrix with the given matrix. Multiply the scalar with the given matrix. We get first one 5 by root 2, second one 5 by, oh, I am making mistake. What is this? 5 by 17 into root 2. Next one minus 20 by 17 into root 2. Next one 5 by root 2 into root 17. Next one 5 by 2 into root 17. This is the P inverse. Now canonical form is P inverse, diagonalization is P inverse A P equal to D. Diagonalize. So canonical form means you don't keep A left side and move P inverse and P right hand side. Diagonalization is diagonal matrix 1, 6. Diagonal eigenvalues. That implies A equal to P D P inverse. Now apply this. This is called canonical form of the given matrix. Reduce the canonical form of the given matrix. P value, whatever is there, you enter. P value is 1 by root 2 minus 1 by root 2 minus 1 by root 2, 4 by root 17, 1 by root 17 plus 1006, and P inverse means whatever you got, you enter the same value. After multiplication, you get this form is called canonical form. Here I am leaving the value 5 by 17 into root 2 minus 20 by 17 into root 2, 5 by 2 into root 17, 5 by 2 into root 17. Okay, this is the approach you find the canonical form. So next part, similar matrix are there. The reduced canonical form, not X. Here I mentioned wrongly. P inverse AP equal to D, where D is the diagonal matrix. Usually diagonal matrix, nothing but diagonal matrix. Last step I made a mistake. In the last step, don't take P inverse AP. P inverse AP, okay. X transpose D. After that, you get P inverse, okay. You get this 1006. No need to keep here. So after that, a canonical form. Therefore, canonical form is X transpose DX. X transpose means take two variables in row wise. D means 1006 x comma y. After finishing this, I can give a clue. Finally, we get x square plus 6y square. First eigenvalue into x square plus second eigenvalue into y square. If you have three eigenvalues, third eigenvalue into z square. This is the canonical form. In the canonical form, only we have squares only. Product of variables does not appear. So this is the canonical form. Okay. This is the canonical form. Next concept or next problem, not a concept. This is the procedure, you remember. Here I provide the canonical form always first eigenvalue into first variable square plus second eigenvalue is into second variable square, nth eigenvalue into eigenvalue square. But this is the procedure, how to evaluate. But if they ask more marks, that time you evaluate all the procedures. Suppose I ask a 2 marks question, no need to evaluate. Simply you find the eigenvalues of the matrix, just substitute in the formula. Reduce the quadratic form to the canonical form and specify the matrix. Here I am going to pick problem from our list. So reduce the quadratic form into canonical form. First of all, it is a quadratic form because it is a quadratic equation. What is the matrix of the quadratic form? 3, x square coefficient is 3, y square coefficient is 5, z square coefficient is 3. xy coefficient is minus 2, half is minus 1. Half of the minus 2 by 2 is minus 1. So keep minus 1 in xy place and yx place. Okay, next xz place we have 2, 2 means 1. Yz place we have y minus 1, minus 2, so it becomes minus 1. This is the given matrix. Okay, matrix of the quadratic form, matrix of the quadratic form. So we have a task to find eigenvalues, eigenvectors. So first step is find eigenvalues. Then find eigenvectors, corresponding eigenvectors. Then normalize eigenvectors. Normalize means you find unit vectors. Then take P, model vector. Find model vector. Model vector means P. P nothing but x1 cap, x2 cap, and so on. Suppose n eigenvectors is there, this. After finding this, if you have any interest, you can multiply P inverse AP, we get D. Okay. Otherwise, no need to multiply directly, you can consider. If you have any interest, you multiply this, we get a diagonal matrix. In the diagonal, eigenvalues, first eigenvalue, second eigenvalue, and so on. Last row 0 0, all are zeros, lambda n, this form, this is diagonal. So we get in this form after simplification. So canonical form is, next step is canonical form. Canonical form is x transpose D, not in place of A, you take D into X. We get a first eigenvalues, final answer is in the form. Second eigenvalue into x2 square plus and so on, eigenvalue into xn square. This process take more time. That's why I skip all the problems. I simply explain the procedure. I pick the previous problem because of this reason. Okay, you practice more in the diagonalization and the quadratic form. Another definitions in the quadratic form. So these are the definition. Index of the quadratic form. The number of positive terms in the canonical form is called index. Actually, find the eigenvalues. Number of positive eigenvalues. The number of positive eigenvalues is nothing but index of the quadratic form, because In the canonical form, all coefficients are eigenvalues. How many eigenvalues have a positive sign? That number is nothing but quadratic index of the quadratic form. Next one, signature of the quadratic form. The difference of the number of positive terms and number of negative terms of the canonical form is called signature of the quadratic form. Identify the number of positive eigenvalues, number of negative eigenvalues. Their difference is called signature of the quadratic form. Positive definite, the quadratic form is said to be positive definite if all eigenvalues are positive. If all eigenvalues of the matrix or quadratic form is positive, then the resultant quadratic form is said to be positive definite quadratic form. Positive semi-definite means eigenvalues are non-negative. Non-negative means either positive or zero. Similarly, negative definite of a quadratic form means the eigenvalues of the quadratic form matrix all are negative. Then it is called negative definition. Negative semi-definite means they are non-positive. Non-positive means they may be positive or zero. They may be negative or zero. So, for example, find the index and signature of the given problem. Here I am explaining here only. Index, how many positive eigenvalues are there? 2. Here 1, here 2. Total 3 eigenvalues are there. Among 3, 2 are positive. So, index is 2. Signature means difference of the index is 2. Number of negative eigenvalues is 1. So, difference is 2 minus 1 is 1. So, signature is 1. This is. Find the nature of the quadratic form. Here it is not in the standard form. Here it is not in the standard form. So reduce this into standard form, canonical form. Find the nature of the quadratic form. Find the nature means either positive definite or positive semi-definite, negative definite, negative semi-definite. First find the matrix, then find its eigenvalues. Then only we decide whether it is a positive definite or positive semi-definite. In the last problem also same thing. Some people evaluate this converted into matrix into square form. For example, factorization method. Some people directly find matrix. It is better to, my suggestion is better to find matrix. Matrix 1, 5, 1. Here by the practice, you can also enter easily. I have some practice, so I can enter quickly. This is the matrix. Find eigenvalues. A minus lambda I. Observe that all eigenvalues are, we get a 3 eigenvalues because it is a 3 by 3 matrix. 1 minus lambda, 5 minus lambda, 1 minus lambda diagonal elements, other elements 1, 3. So next 1, 1, next 3, 1, whose det equal to 0. Simplify this equation, we get 3 roots. Observe that their sign, whether they are positive, all are positive, one is negative, one is 0, other one is positive, like that. If all are negative, it is called negative definite. If all are positive, it is called positive definite. If negative along with zeros are included, then it is called negative semi-definite. Similarly, positive and zeros are involved, then it is called positive semi-definite nature. So it is a quadratic form. So I leave this problem, yourself do it. It is better. So my suggestion is some people doing this factorization method also. Is there any factorization between x, y using this x, y whole square like that? It takes more ideas. We need more ideas, more analyzation to do this manner. So my suggestion is it is better to convert into matrix form and find eigenvalues. They are all are positive, all are negative, and decide. So 5 minus lambda, 1 minus lambda, 1. Here 1 times of 1 minus lambda minus 3 plus 3 times of 1 minus 3 times of 5 minus lambda equal to 0. 1 minus lambda, this value is lambda square minus 6 lambda plus 5 minus 1. Here minus 1 times of minus lambda minus 2 plus 3 times of 1 minus 15 plus 3 lambda equal to 0. Here lambda square, I am doing a very 6 lambda plus 4 without explanation because it is better to finish quickly. 6 lambda square plus 4 lambda plus lambda plus 2. Here we get 15 minus 1 minus 14. Minus 14 into 3 is 42. Minus 42 plus 9 lambda equal to 0. Now simplify this, we get a quadratic cubic equation. Lambda cube 1 lambda cube, lambda squares here one term, here one term. So minus plus 6 lambda, that means plus 7 lambda square. Here minus 6 lambda, here minus 4 lambda, total minus 10 lambda, minus 10 lambda plus lambda minus 9 lambda, minus 9 lambda plus lambda minus plus 9 lambda 0. So lambdas are disappears, only remaining 4 constant term plus 2 minus 42. 4 plus 40 minus 40 minus 4 means minus 36 equal to 0. What are the roots of this cubic equation? 0 is not a root because it is a cubic equation. It has 3 roots. 1 is not a root. Minus 1 is not a root. What about 2 plus 2? So plus 2 is a root. Therefore, plus 2 is a one of the root. So apply the synthetic division. So 0, 2, oh, sorry, 1 into 2, 2, adding these two 9, 9 into 2, 18, adding these two 18, 18 into 2, 36, plus 36, adding these two, we get 0. Therefore, factorization of this equation is lambda minus 2 into lambda square plus 9 lambda plus 18. So what about these two roots? Lambda equal to minus b plus or minus square root of b square minus 4ac. 4 into 18. 72 by 2a. Lambda equal to minus 9 plus or minus 81 minus 72. 72 means 8. 8 plus 1 means 9 by 2. Here we get minus 9 plus or minus 3 by 2. Take 3 is a common fact. No use. Anyhow, minus 9 plus 3 by 2, one of the root. Another root is minus 9 minus 3 by 2. So the roots are minus 9 plus 3 means minus 6. Minus 6 by 2, one of the root. Here minus 12 by 2. So roots are minus 3 or minus 6. First one is 2. Lambda equal to 2. So different natures are there. One root is 2, minus 6, minus 5. So one is positive, other two are negative. So index is 1, index is 1. So signature is minus 1. But it is not any one of the model, neither positive definite nor semi-definite. It is neither positive definite, neither negative definite, neither semi-definite, negative semi-definite, negative positive semi-definite. So this is not any one of the above 4 types. Okay, this is the concept, last concept of this unit. So I'm stopping here. You do the practice all the problem.